Welcome back to Makerium. In a world shaped by creators and dreamers, this channel is where ideas take physical form. In this video, you are invited into the building process of a hobbit home, crafted slowly, thoughtfully, and by hand. Alosha is driven by a lifelong passion for the design of curvilinear forms found in nature, alongside bioarchitecture inspired by the work of Antonio Gaudi. This is a journey of imagination grounded in earth, wood, and craft where vision becomes shelter and dream becomes home. After the soil is excavated, upright support poles are prepared to prevent the wall logs from collapsing inward, to create a waterproof barrier. The ends of the logs are burned and hot asphalt is applied to the lower portion of each pole. The poles are then placed into the holes on the gravel bed. Large rocks are hammered and compacted around the poles. This tight compaction provides structural strength and secures the assembly in place. The vertical support poles then become completely solid and immovable. The wall logs are placed horizontally between the upright support poles, with only dry, dead logs used to ensure durability. Partially rotten logs are still harvested from the forest, but are repurposed as firewood rather than included in the structure. The log placement is carefully planned in advance to avoid obstacles and allow smooth installation. Ropes and heavy-duty digging bars are used to control the logs, guide them into position, and prevent them from rolling. Once the logs are in position, the surrounding soil is compacted around them, providing additional support and securely anchoring the structure. This compaction also helps prevent settling or shifting over time, especially for the sections of the logs that are partially buried. According to the plan of the hobbit home, the ceiling is arched. These arches are constructed using low-grade timber planks, selected for their combination of strength and affordability. To form each arch, the bending process begins by placing the timber planks in a wooden jig, with several pegs driven into the ground to distribute pressure evenly. The planks are bent carefully to determine the maximum height achievable without snapping. Each arch is made of 3 planks, stacked and fastened with screws and nails, creating the full thickness. Additional patches are added as needed to reinforce the connections. Sockets are cut into the log walls to receive the arches. The size and depth of each socket are measured precisely to ensure a snug fit, allowing the timber arches to sit securely without gaps. This integration reinforces the connection between the horizontal wall logs and the arched ceiling above. A ratchet hoist is used to adjust the arches to the right size, since timber naturally tends to relax and straighten overnight. It keeps the tension under control, preventing any sudden movements that could damage the planks or throw off the fit in the wall sockets. Temporary wooden supports and jacks are used to hold the arches in place while they're being installed. These supports keep the curved timber sections stable, taking the weight off both the visible ceiling and the hidden connection points in the log walls until everything is securely in place. If you're following along and enjoying the build, please like the video and subscribe. It's the most effective way to support our work. The front and back log walls are non-load bearing, meaning they define the vertical edges of the vault without supporting any structural weight. Each log is carefully stacked in place, with close attention paid to keeping the courses level and the joints tight. The T-beam is installed below the arched ceiling, spanning from the front log wall to the back log wall. It's carefully placed to add extra structural support and to clearly define the central axis of the vault. Next, the main column is prepared. A rectangular section is carefully cut into the timber so it fits snugly beneath the lower flange of the T-beam. This shaping allows the column to act as a stable vertical support, safely transferring the load from the beam above down into the foundation. In addition, a small cutout footing is formed to keep the vertical member from sliding along the log. This recessed detail locks the base of the column in place, acting as a mechanical stop that resists side-to-side movement. This simple but effective step keeps the vertical support properly aligned over time, even as the surrounding materials settle or shift due to moisture in the ground. The bottom of the column is set in place first. Then, the top is lifted, raising the whole assembly by about 10 centimeters. This slow adjustment lets the T-beam above settle evenly onto the column, ensuring the load is transferred correctly without disturbing the surrounding logs or foundation. Next, diagonal lattice rhombus struts are installed. This lattice adds rigidity to the vault, keeping it stable against forward, backward, and diagonal movements, as well as external forces. Two more timber pieces are then added to form an outer arch. The outer struts handle tension when bending, while the inner strut works in compression. Together, they reinforce the vault's stability and efficiently distribute loads throughout the hidden structure beneath. Next, the outer roof struts are installed, forming the framework that will support the waterproofing layer, 2 layers of insulation, the clay lock, the earth berm, and the expected snow load. Once all the roof timbers are in place, they're treated with copper sulfate to prevent fungal growth and extend the structure's durability. To protect the structure from the weather, a temporary plastic layer is laid over the roof to keep it dry until work resumes. The next day, the vapor barrier is installed, followed by 2 layers of foam insulation, which provide thermal protection while maintaining the roof's structural balance. For waterproofing, a heavy bitumen membrane is used to hold the roof layers in place. Because the membrane is brittle, the work is done on a warm day to prevent it from tearing. joints of the bitumen membrane are adhered using the burning method. Each section is carefully warmed until the material becomes adhesive, allowing the sheets to bond securely to one another. This process ensures a continuous, watertight layer that protects the underlying insulation and timber framework. Once the waterproofing is complete, the longer roof timbers that act as a sun and rain awning are cut to their final shape. Each piece is trimmed to follow the intended roofline, creating a consistent overhang and directing water runoff away from the structure. The cuts are made with care so the awning blends seamlessly with the finished roof, offering protection from sun and rain while also enhancing the overall look of the visible part of the Hobbit home. Beyond providing protection, the awning also helps with environmental control. The shade from the overhang reduces heat gain on walls, openings, and entrances, helping to moderate indoor temperatures. In wetter climates, the awning also makes exterior areas more usable by keeping entry zones dry and safe. Metal flashing is installed by bending sheet metal to a 90-degree angle, allowing it to support the grass turfs while following the curve of the roof. Each piece is carefully shaped to create a continuous edge and to keep the soil in place once the earth covering is added. At the front of the structure, the exposed timber struts are treated with linseed oil for added moisture protection. This treatment improves the timber's resistance to water absorption and weathering, complementing the metal covers that provide extra protection. Air pipes are installed to provide ventilation throughout the structure. PVC piping runs from lower exterior intake points to higher interior outlets, promoting natural airflow and allowing incoming air to be slightly warmed during winter. The pipes are insulated to minimize heat loss and condensation, and the surrounding soil is gently compacted to hold them securely without causing any deformation or damage. At the rear of the structure, the back wall is built from cedar off-cut slabs fitted between the foundation log and the earth wall. The slabs are placed tightly to create a stable enclosure while making efficient use of available materials. A plastic barrier is added at the base to prevent water from seeping in. The main structure of the Hobbit home is now complete and is ready for the finishing touches that will help it blend seamlessly into the surrounding landscape. The burning stovepipe chimney is installed to safely and efficiently vent smoke and combustion gases. All connections are sealed and supported for stability, and any roof penetrations are reinforced and waterproofed to prevent leaks. The pipe is carefully aligned with the stove outlet, keeping safe clearances from combustible materials to meet safety standards. Once installed, the chimney is checked to ensure proper draft and unobstructed airflow for optimal performance. The next step is covering the roof so it blends seamlessly with the surrounding landscape. Soil is gently compacted and shaped over the roof to create a stable base, while a clay lock is applied to keep it from sliding once the turfs are layered on top. The clay lock is prepared in a cement mixer with straw to increase tensile strength and prevent cracking. It is then applied by hand, pressed, and shaped to form a continuous layer. This labor-intensive process takes several days, as care is taken to achieve a uniform thickness and ensure proper adhesion to the roof timbers and insulation beneath. The clay lock is an ideal stabilizer, even under rain, wind, and seasonal expansion or contraction. Its malleable nature allows it to conform to the contours of the arched roof, creating a solid yet flexible foundation for the living layer above. This secure interface between the roof structure and the vegetation improves natural insulation, aids in water management, and helps the turfs adhere perfectly. After applying the clay lock, additional clay and subsoil are added to form stepped terraces that follow the curve of the vault, reminiscent of a Mayan pyramid. Each step is carefully leveled and compacted to prevent turf slippage. Shaping the roof this way allows the structure to blend seamlessly with its surroundings, providing thermal mass, natural insulation, and a harmonious transition between the built and natural landscape. The layered earth also supports vegetation, promotes biodiversity, and helps manage rainwater, transforming the roof into a functional and sustainable living part of the home. The grass turfs are sourced from the original cutouts from the house, the future berm, and the pathway leading to the home. Each turf is carefully placed onto the prepared soil and clay lock and pressed firmly to ensure full contact with the underlying surface. Over time, the roots grow down into the soil, firmly anchoring the turfs to the roof. The straw in the clay lock helps retain moisture, supporting healthy root growth and stabilizing the living roof. As the grass matures, it forms a self-sustaining green covering that blends with the surrounding landscape and enhances the authentic hobbit home appearance. For the front wall, a non-load-bearing structure is built to support the glass facade. Logs are lifted into place using ropes and metal rods, with each one cut to fit around the upright columns. As the logs are positioned, the earth behind them is gently compacted without disturbing the protective plastic that is laid along the base, where the logs meet the soil. Any plumbing or electrical pipes are routed according to the building plan before the space between the walls and the earth is filled. Building with logs is treated as a creative and adaptive process, allowing adjustments by adding blocks or trimming individual pieces as needed. Because logs are naturally irregular, they are carefully shaped and fitted using tools like chisels, chainsaws, and saws to achieve precise alignment. Foam is applied to fill the gaps between logs, ceiling joints, and keeping cold air out. This insulation step improves the wall's thermal efficiency, reducing heat loss and minimizing drafts. This also dampens sound and provides a flexible barrier that accommodates small movements in the logs caused by settling or seasonal expansion. The next day, Alosha's friend, a professional carpenter, arrives to cut a trench for the glass wall. The trench is first marked with 2 parallel lines, each 5 millimeters wider than the thickness of the triple-pane glass. Precision and level alignment are important, though achieving perfect accuracy with a chainsaw is challenging. They're great for removing large amounts of material quickly, but they're less precise than hand tools, so careful planning and marking are essential. Small deviations can easily occur, and even minor unevenness may create pressure points or gaps when installing delicate materials like glass. To correct this, the trench is cleaned and leveled using a wooden chisel. The glass wall installation follows a straightforward, logical sequence. A cleaned plank is first placed to support the glass and securely screwed into the thick central rectangular column. Next, upright boards are installed. Since the wall is non-load bearing, the central column carries most of the structural weight, while the upright boards mainly help hold the glass securely in place. Along the arched portion of the opening, an additional curved plank is installed to act as the upper frame for the polycarbonate glass, allowing the glazing to sit evenly and securely. Foam pipes are placed into all cutouts where the glass panels are installed. By absorbing minor movement and compensating for small irregularities in the wood, they prevent point loading and reduce the risk of cracking. During the loading of earth onto the roof, a slight buckling is observed on one side of the vault. The issue is solved by installing an additional upright rectangular column to reinforce the structure. To accommodate this new support, the front wall logs are pre-cut by approximately 2 inches, allowing the column to be fitted properly and aligned with the existing framework. Extra care is taken when making these cuts with the chainsaw. While edge cutting can feel precise and efficient, it carries a risk of upward kickback if not handled correctly. The column is installed and the vault stability is restored, reinforcing the structural integrity of the roof. After all the glass panels are in place, the small triangular section at the top is finished with polycarbonate, a choice that proves advantageous. It creates a continuous, clear surface, preserving the elegant curve of the opening. It's recommended to install polycarbonate on both the front and back for added insulation and protection. For the door, a piece of plywood serves as the main panel. A geometric cutout is made in the center for the glass, allowing extra natural light to enter the home while adding a design feature that reflects the distinctive aesthetic of a hobbit-style dwelling. Once the glass is installed, it is secured with an inner frame, and the remaining spaces in the door are filled with rigid foam insulation to provide thermal protection during cold winter days. The combination of protective finishes and thoughtful design results in a door that is energy efficient, visually appealing, and reflective of the handcrafted, organic character typical of earth-integrated homes. If you've watched all the way through, we want to sincerely thank you. Your support means the world to everyone involved in this project. You are one of our most dedicated viewers, and we truly appreciate it. We're committed to making our next video even better for you. If you enjoyed this one, please consider hitting the like button and subscribing. It really helps us more than you know. Thank you again for your continued support. Faux leather and nails with decorative caps are often used to add the finishing touches to the inner side of the door. Because the door is relatively heavy and strong, properly rated hinges are installed to ensure smooth, reliable operation over time and safely support the panel's weight. The exterior work is nearing completion, with focus on closing every open void and addressing all remaining details. Each gap, joint, or unfinished section is carefully inspected and corrected to ensure resilience, weatherproofing, and visual harmony, fully protecting the structure from the elements. Plywood is cut into a decorative, curved shape to form the windowsill, with contours designed to echo the arches of the roof above. The sill doubles as a seating area, providing a comfortable spot for morning coffee while offering unobstructed views of the surrounding landscape. Living in this hobbit-style home is more than just having shelter. It's an experience of connection to the earth beneath, to the natural rhythms of light and weather, and to the joy of handcrafted design. It's a small world where creativity, comfort, and nature come together in perfect harmony, evoking a sense of peace and wonder. If you like this project, be sure to subscribe and stay tuned. More exciting videos are coming soon.